What if everything you thought you knew about Saturn's rings was wrong? Not wrong in some small way, but fundamentally, staggeringly wrong. For centuries we assumed these glittering bands of ice were as old as the planet itself, silent witnesses to the birth of the solar system 4.6 billion years ago. Then data from the Cassini spacecraft delivered a verdict that stunned scientists everywhere. The rings are young. Shockingly young. So young that when they formed, dinosaurs were already walking the Earth. That single discovery cracked open a much bigger mystery. If the rings are not ancient, then something violent must have created them, and recently. In February 2026, a team of researchers finally pieced together what that something was. It turns out the answer had been hiding in plain sight all along, inside the gravity of Saturn's largest and most famous moon, Titan. This is the story of a slow-motion catastrophe that reshaped an entire planetary system, and it begins nearly 400 years ago with a confused Italian astronomer. In 1610, Galileo Galilei pointed his telescope at Saturn and saw something he could not explain. The planet appeared to have two enormous companions pressed against its sides. 2 years later they vanished entirely, only to reappear as strange curved arms sometime after. What Galileo was actually seeing was our shifting view of Saturn's rings, tilted at 27 degrees, sometimes edge onto Earth and nearly invisible, sometimes angled wide open. It took another astronomer, Christian Huygens, until 1659 to correctly identify the arms as a ring. Huygens also discovered Titan itself. Soon after, Giovanni Cassini spotted 4 more major moons, Iapetus, Rhea, Tessis and Dione, and in 1675 found a dark gap cutting through the rings that still bears his name. Centuries later, in the 1970s and 80s, the Pioneer and Voyager probes revealed the rings were not solid sheets at all but countless individual particles, each one a tiny satellite in its own right. Then came the Cassini spacecraft, which orbited Saturn for over a decade, threading the gaps between the rings before diving into the planet itself in a final blaze of data. What it found rewrote the textbooks. Saturn's rings stretch out nearly 282,000 kilometers from the planet, yet in places they are barely 10 meters thick. They are named D, C, B, A, F, G and E, along with a faint outer Phoebe ring far beyond the rest. Small moons called shepherds, Pan, Daphnis, Prometheus, Pandora, Janus and Epimetheus, hold the ring particles in line, while the moon Mimas, discovered by William Herschel in 1789, exerts outsized control from further out. By the end of the Cassini mission, Saturn's moon count stood at 62. Today, thanks to better telescopes, that number has climbed past 292, more than any other planet, and includes bizarre little ring moons shaped almost like ravioli, coated in dust swept up from the rings themselves. Cassini also confirmed the rings are made almost entirely of water ice, about 99.8%, with particles ranging from grains of sand to chunks the size of mountains. That ice is what gives the rings their brilliant shine. But this brightness posed a problem. Space dust constantly rains down and darkens exposed ice over time, so bright rings should mean young rings. Using the total mass of the rings, roughly 16 quadrillion tons, a tiny fraction of our own moon's mass, scientists calculated how quickly they would have darkened. The math pointed to an age of only 10 to 100 million years. Compared to the 4.6 billion year age of the solar system, that is nothing. Dinosaurs had already existed on Earth for around 150 million years before Saturn's rings ever formed. So how does a ring system suddenly appear around a mature planet? In 1849, mathematician Edouard Roche proposed an answer. He showed that a moon orbiting too close to its planet would be torn apart by tidal forces, the same forces that cause ocean tides on Earth, its shredded remains spreading out into a ring. He calculated this danger zone, now called the Roche limit, at about 2.5 times a planet's radius. For Saturn that works out to 87,000 kilometers, a distance that lines up neatly with the outer F ring. In 2022, a team at MIT proposed that a lost moon, which they named Chrysalis, once orbited between Titan and Iapetus. They suggested Titan's gravity gradually pushed Chrysalis inward until it crossed the Roche limit and was destroyed, its debris becoming the rings. It was an elegant idea. But when researchers at the SETI Institute modeled the scenario more carefully, publishing their results in February 2026, they found a serious flaw. In their simulations, Chrysalis was far more likely to collide directly with Titan than to be gently nudged toward Saturn. And a direct collision would not scatter debris into a ring system at all, most of it would simply be swallowed by Titan or lost from the system completely. There was another clue the Chrysalis model could not explain. Hyperion, a small, misshapen moon that tumbles chaotically as it orbits, kept vanishing in the simulations. Yet Hyperion is still there today, locked in a stable relationship with Titan's orbit. Astrophysicist Mottier Cook and his team, leading the SETI study, realized this relationship was surprisingly young, and that its age lined up almost exactly with when Chrysalis was supposed to have disappeared. Hyperion was not a leftover survivor of some other event. It was the direct result of one. Cook's team modeled the entire Saturnian system together rather than treating each mystery in isolation, factoring in Saturn's odd 27-degree tilt and the orbits of its many moons. Running dozens of simulations, they found that an object they called Proto-Hyperion, 4 times more massive than the earlier Chrysalis idea, actually collided with an earlier, smaller version of Titan. Out of 60 simulation runs, 42 produced this collision. In the runs without one, either Proto-Hyperion or Iapetus was flung out of the system entirely. The team dated the impact to around 400 million years ago. Here is how the chain reaction unfolded. At some point Saturn slipped out of a long-standing gravitational rhythm with the other planets in the solar system. That small shift was enough to destabilize Proto-Hyperion, locking it into a powerful 2-to-1 resonance with Proto-Titan, the strongest kind of gravitational lock there is. For every orbit Proto-Titan completed, Proto-Hyperion completed too, and this pulled Proto-Hyperion steadily inward. Along the way it also yanked at Iapetus, tilting that moon's orbit dramatically. Eventually Proto-Hyperion and Proto-Titan crossed paths, and they collided. The impact reshaped both moons forever. Titan, already larger than the planet Mercury, was resurfaced by the violence, smoothing over ancient craters and explaining why its surface today looks so surprisingly young and largely free of impact scars. Some of the wreckage from Proto-Hyperion merged into Titan itself, while the rest slowly reassembled into the small, oddly shaped, low-density moon we now call Hyperion, its chaotic tumbling a lasting scar from the collision. Soon after forming, Hyperion was captured into its current 4-to-3 resonance with Titan. The collision also flung Titan onto a highly stretched, elliptical orbit, a process that only accelerated afterward. Cassini data shows Titan is migrating away from Saturn today far faster than expected, at roughly 11 centimeters every year, a speed this ancient collision helps explain. The consequences reached even further, all the way to Saturn's own axis. As Titan's orbit expanded and changed shape, it altered the wobble, or precession, of Saturn as it spins, much like a slowing top. This growing wobble pushed Saturn's spin axis into a resonance with the orbit of distant Neptune. The only way that lock could be maintained as Titan kept drifting outward was for Saturn itself to tilt over, eventually settling at the 27-degree angle we observe today, a tilt that had puzzled scientists for decades since giant planets are expected to form with almost no tilt at all. For roughly 200 million years afterward, the system found a fragile stability. But Titan's outward drift never stopped, and about 100 million years ago it locked into a new 4-to-1 resonance with a pair of inner moons. This tilted Titan further and dragged the 2 inner moons into colliding orbits of their own. When they finally smashed together, tidal forces from Saturn tore the wreckage apart. Some of that debris reassembled into new moons. The rest spread out into the thin, glittering disk we know today as Saturn's rings. Every strange feature of this system now traces back to a single cause: the tilted orbit of Iapetus. The improbable age and shape of Hyperion. Titan's thick hazy atmosphere and suspiciously young surface. Its stretched, rapidly expanding orbit. Saturn's own 27-degree tilt. And finally, the bright, youthful rings themselves. One collision, 400 million years ago, set every domino in motion. Confirming this story further will fall to NASA's Dragonfly mission, a nuclear-powered, car-sized rotorcraft set to launch in 2028 and reach Titan